Hi friends, here is Lucas. This is a free lesson from my best-selling course about Kotlin coroutines and Flow for Android development. You can find the link in the description to get the course for a nice discount. Alright, in this lecture we are going to improve the code of the view model even further by using the asLiveData terminal operator. In fact, our code here in the view model in this current state actually has a very big problem. To illustrate why there's a problem, let's switch to our stock price data source. And here, let's use Timber to log out fetching current stock prices whenever the data source performs a network request in order to retrieve the current stock prices. I'm using the tag flow here for this Timber log message so that we can later better filter our log messages with logcat. So with this log statement here, we can then, when we run the app, check if this data source is still active and is still fetching stock data from the network and emitting them to the flow. So if we now run the app and open up logcat and filter for flow, and then when we switch to the app and navigate to the first use case, you can see in logcat that the data store starts to fetch stock prices, and every 6 to 7 seconds a new line is logged out. Now the problem that we currently have is that even when we put the app into the background, so when we put it into the background, you can see in logcat that still new log lines are printed out. So the data source is still fetching new stock prices from the network, which is a problem. And that's not only a small problem, but a very big one, because these network requests cause unnecessary loads to the servers. Additionally, they also waste a lot of resources on the device of our users, and we definitely need to avoid this. What we need to avoid is to have such a infinitive flow that never stops, but instead what we need is a flow that stops when the app is in background and restarts again when the app comes back into the foreground. So let's now switch to the view model, and our goal now is to cancel the flow when the app gets into the background. A first naive solution would be to simply create a new job property. And then assign the job to the job that the flow pipeline with launchIn returns. Let's move this assignment into its own function. And also create another function called stopFlowCollection, in which we cancel the job, which leads to the cancellation of the flow. Let's now remove the private modifier, and also we remove the initializer block. Let's also define the stock price data source as a property, so that we can get rid of this parameter here in our start flow collection function. Alright, this is the naive solution of the view model. In the view model, we now have two functions, one function to start the flow collection and another function to stop the flow collection. And what we need now is to switch to the activity, and in the activity we need to override the onStart lifecycle function. And in there, let's call viewModel.startFlowCollection and also override the onStop lifecycle function. And in there, let's call viewModel.stopFlowCollection. So now when the activity starts, we start the flow collection, and whenever the activity goes into the background, the onStop function is called, and then we call viewModel.stopFlowCollection. And this should accomplish our goals to stop the flow when the activity goes into the background, and when it comes into the foreground, the start flow collection should be triggered again, and then we should receive stock prices again. One thing we should do additionally is to go into the view model again and add an onCompletion block. And in the onCompletion block, let's add a timber log statement in which we simply log out when the flow completes. This way we can check then in logcat if the flow was actually cancelled. So let's now restart the app. And when we now open flow use cases, use case number 1, you can see that the data store starts to fetch the stock prices every 6 to 7 seconds. And once we click on the home button to put the app into the background, you can see that flow has completed, is printed out. So indeed, our data source stops its work. There are no more network requests performed, but instead the data source is inactive and no device resources are wasted. If we put the app in the foreground again, you can see that now new stock prices are fetched and emitted, and here again, and our UI also updates every 6 to 7 seconds, so the app works as desired. So this naive solution here works as expected. However, it has two big drawbacks. And the first drawback is that a lot of boilerplate code is needed. So in the view model, we need this additional reference to the job, and we need these two functions, start flow collection and stop flow collection, and we need to assign the pipeline to the job, and that's all a lot of manual work to do that's error prone and can easily lead to errors. And not only code in the view model is needed, also when we switch to the activity, we need to call start flow collection in the onStart method, and in onStop we call stop flow collection. So a lot of boilerplate code, and that's obviously really bad. The other big problem here is that whenever there's a configuration change, the flow gets cancelled. And that's actually not what we want. So if there's a configuration change, so for example, when the user changes the device orientation, or when the user switches the app to multi-window mode, or for example, when the user switches from dark to light mode, then the activity is recreated. And whenever this happens, right now, our flow is cancelled, and a short period afterwards restarted again. And we actually want to avoid this cancellation and this immediate restarting of the flow. So to demonstrate this, when we, for example, just change from light mode to dark mode, then you can see visually nothing changes because we haven't adjusted our app based on light mode or dark mode. But on the other hand, in logcat, you can see that the flow was cancelled because the activity was destroyed, and shortly afterwards it was recreated, and then the flow was restarted. And this restarting should be avoided. And what would be better would be that the flow isn't even cancelled, but continues to run in situations like configuration changes. So we need a better solution here. Okay, I reverted the changes of our previous solution again. And now I want to show you the proper solution. And this one can be achieved by using the asLiveData terminal operator. So instead of launchIn, we can use asLiveData. And what this new terminal operator allows us is that it directly converts a flow into a LiveData object. Since LiveData is a type of the Android X lifecycle library, the asLiveData terminal operator is not defined in the Kotlin X coroutines library, but in the Android X lifecycle library as well. Well, to be precise, the library is called Android X lifecycle LiveData KTX. And since we have already added this dependency in our build.gradle file before, we are ready to use it. So let's now switch back to the view model. And let's first open up the official documentation of the asLiveData operator to find out about what this operator is all about. The documentation says that it creates a LiveData that has values collected from the origin flow. So as you can see, asLiveData is an extension function on a flow, and it returns a LiveData with the same type as the type of the flow on which it is called on. So it has the same type as the origin flow. In our view model here, the origin flow is the one we get from the latest stock list property of the data source, which is a flow of a stock list. However, the map operator returns a new flow that is a flow of UI states, and therefore asLiveData creates a LiveData object that emits UI state objects. Now, since we get a LiveData object directly from the call to asLiveData, we can directly assign the pipeline to the current stock price asLiveData property. So we can remove the initializer block and directly assign it. Since asLiveData returns a LiveData object and not a mutable LiveData object, we switch the type here. And there's also an error here in the on each block where we want to set the value of the LiveData object to the emitted UI state, but this is not possible anymore because now this LiveData property is a LiveData object and not a mutable LiveData object, and so we can't assign new values to it. In fact, with asLiveData, we don't even need to manually assign UI states to this property, since that's what's basically the asLiveData operator is doing, so we can remove the on each block altogether. So to sum it up, the asLiveData terminal operator is called on a flow, in this case on a flow of UI states, and converts this flow into a LiveData object that emits UI states. Now our code looks very short and nice. Or what do you think? Let's now verify that this code is not only beautiful, but also functional, and it is doing what we want it to do. Therefore, let's again add an onCompletion block to see if our flow actually gets cancelled. And let's now run the app. And when we now navigate to the use case, you can see that logcat prints out that the stock prices are fetched, so the data source becomes active. And when we now put the app into the background, you can see that after about 5 seconds, it will print out that flow has completed. And I will tell you later why this is 5 seconds after we put the app into the background. When we now bring the app into the foreground again, then yes, the data source should become active again and network requests should be happen now again. And as you can see in logcat, this is the case, and we get new data and new stock prices are then displayed within the app. The asLiveData terminal operator is, when we compare it to other terminal operators like collect or launchIn, a bit strange. For the other terminal operators, we had to either start a new coroutine, as it was the case with the suspend function collect, or we at least had to pass a scope, like for instance with launchIn, so that launchIn can then internally start a new coroutine. However, here with the asLiveData operator, we don't need to do any of these two options. We don't need to create a coroutine, but we also don't need to pass a scope. So how does asLiveData work? Let's have a look at the internals of asLiveData to find out more. So I press the command key, and when I then click on the asLiveData operator, I get into the implementation. And here you can see that it uses the LiveData builder. And to the LiveData builder, it passes this block here, where it collects from the origin flow and then emits this value to the LiveData property. So here, this emit means that it doesn't emit to a flow, but it emits a new value to our LiveData property. When we now take a look at the LiveData builder function here, you can see that this one returns a coroutine LiveData object. And when we have a look into such an object, when we scroll down a bit, you can see that in this coroutine LiveData object, a new scope is created, a new coroutine scope is created with the dispatchers.main.immediate dispatcher and also some other context elements. And this scope is then passed to a so-called block runner. When we search for the block runner where it is used, you can see that whenever the LiveData object gets active, so in our case, when the activity that observes the LiveData object gets into an active state, the block runner.maybeRun function is executed. On the other hand, when the LiveData object gets inactive, so in our case, when the activity goes into the background, the block runner is cancelled. Let's now have a look at the maybeRun function of the block runner. And here you can see that a new coroutine is created, and in there the block is executed, which we saw before, the block that collects from the origin flow and emits these items to the newly created LiveData object. So to sum up what's happening inside the asLiveData terminal operator is that we don't need to pass a coroutine scope, but instead this scope is created internally. It's based on whether the LiveData is active or not. On this scope, a new coroutine is launched, and in this coroutine, the actual collection happens. But let's switch back to the view model now. Let's have another look at the asLiveData documentation. As you can see, we can pass two different parameters here, a coroutine context and a timeout in milliseconds. The context that we can pass here is passed to the coroutine scope that is created internally, and this is the one that we have seen before. And with this parameter, we are able to override the context elements by passing our own context here. So what we could do now is to pass a different dispatcher, for example the default dispatcher, to it. And this now overrides the internally used context, and therefore the default dispatcher will be used to collect the items instead of the main dispatcher. So this now means that the whole flow, so starting from the flow builder code, but also the code that happens in the operators, will be executed on the default dispatcher. But this is not needed in our case here, so let's remove this parameter again. The second parameter that we can pass to the asLiveData operator is the timeout. As you saw earlier, the flow collection was not cancelled immediately after we put the app into the background. Instead, the asLiveData operator waits for this specified timeout after the LiveData observer gets inactive, and only then cancels the flow. This behavior is necessary so that when configuration changes happen, so when the observer is in the inactive state only for a very short time, we don't need to cancel the flow and then restart it again. And with this timeout parameter, we can adjust the behavior. However, in most cases, the default timeout of 5000 milliseconds should be fine. If we would set the timeout in milliseconds to 0, we would have the same behavior here as with our first solution that we had before, which means that as soon as an orientation change happens, the flow would be cancelled, and then a couple of milliseconds later, the flow would restart again. But in our case here, by leaving the timeout to the default value of 5 seconds, the flow is cancelled 5 seconds after the observer gets inactive. So when the configuration change happens, the flow stays active and is not cancelled. And that's exactly what we wanted to achieve. I can also show you this behavior when we run the app. And when we go into the use case, and then the data source is active, and when we only do a configuration change, like for example changing from light mode to dark mode, you can see that this on completion block is not executed because the flow does not get cancelled, but instead it continues to run. Only if the LiveData observer is inactive for 5 seconds, then the flow is cancelled. So when we click the home button to put the app into the background and wait for 5 seconds, then flow has completed is printed out. All right, great. In this lecture, you learned all about the asLiveData terminal operator, and our code looks pretty nice now and works properly without big problems. So if you want to dive deeper into coroutines and flow, then I can highly recommend my complete course that contains everything to fully understand and successfully use coroutines and flow in your apps. We will together create a stock live tracking app that uses flow extensively. You will also learn about state flows, shared flows, channels, and many other topics. You can find a link to the course in the description, and I would love to have you on board.